A nation without a vision of what the future can be is bound to repeat past errors over and over again. This brief video will outline a vision designed to avoid old mistakes. As an example of the intelligent application of a systems approach, efforts fall short of the potentials of modern technology. Repairing outmoded cities results in higher costs of operation and maintenance. It can make available to all people the most advanced amenities that modern science and technology can provide. It could be the hub and learning center where people from all over the world visit and hopefully emulate this design approach in other parts of the world. Design considerations for these new cities include its overall functioning, its ease of assembly. This systems approach envisions assembling entire cities by standardizing basic structural elements, which are prefabricated in automated plants and assembled on site. Many of these buildings would be comprised of standard units that can be arranged to meet many different requirements. This approach means that these cities can be extremely cost efficient because only one sector needs to be designed, which can be duplicated, integrated city systems anywhere in the world. The outer perimeter will be part of the recreational area with golf courses, hiking and biking structure. The apartments are lightweight and high strength. All of the dwellings are designed as self-contained residences. The outer surface of these efficient structures serve as photovoltaic generators, converting solar radiation directly into electricity for heating, cooling. The wide range of individual homes are prefabricated and relatively maintenance-free. Fire can be mass-produced efficiently and economically. New energy-efficient systems can be installed to supply enough power to operate the entire household. Horizontally, vertically, and radially anywhere in the city. This minimizes the need for automobile transportation, except for emergency vehicles. Transportation between cities would be by monorail, which display information on weather, agriculture, transportation, and the operation of the whole city. This cybernated system will use environmental sensors to help maintain a balanced load economy, which avoids overruns and shortages. The architectural structures themselves will be jewels of future possibilities, with a wide variety of exhibition buildings. Many of the displays will depict not what the future will be, but what it can be. So it would contain residences, parks, recreation, entertainment, healthcare, educational facilities, and more. Everything built in these cities would be as near to a self-contained system as conditions allow. Colonization of the oceans is one of the last frontiers remaining on Earth. Prodigious oceanic city communities will evolve as artificial islands, floating structures, undersea observatories, and more. These large marine structures are designed to explore the relatively untapped riches of the oceans and provide improved mariculture, freshwater production, energy, and mining. This could offset land-based shortages. They could also provide almost unlimited riches in pharmaceuticals, chemicals, fertilizers, minerals, oil, and natural gas. If we use science and technology with human and environmental concerns, it could be a vivid future showcase of the human potential when working together to preserve the greatest gift we have, the resources and beauty of our planet Earth. In the final analysis, we are one people.
Imagine a school that's not just energy independent, but a school that's an energy provider. Now, this is a classroom I would have been excited to be in. There's a display, not just at the head of the class, but on every desktop. Large scale, seamless, thin, durable glass. all of it fronting low power, small footprint operating systems that communicate and serve as displays for personal computing devices. Look at this. Had these been at school when I was a boy, you wouldn't have been able to get me out of the classroom. This is the class community activity table. And again, we see large-scale, seamless design, logic-enabled, durable, multi-touch glass. This may look like science fiction, but these already exist today. Perhaps not in this size or in this setting. But tables with interactive touch surfaces like this are being readied and deployed now. As software and touch interfaces advance, Corning expects community activity tables and interactive wall displays to be featured in classrooms globally. Now let's go and see what Dad's up to. Beautiful, isn't it? All that logic encased in low profile, thin, resilient, touch-sensitive glass. I know what you're thinking. Why would one want an all-glass room? Well, for starters, these walls could be active displays and configured for different situations depending on the required purpose of the room. That inhibits the growth of microorganisms. With that, our tomorrow could be a safer place. Pretty amazing, isn't it? All that data, captured a world away, transported, then displayed here, all in the blink of an eye. Wow. Although, just imagine the bandwidth needed to carry the data for this projection. And for that next generation high-definition glass video display, simultaneously. Yeah, a lot. Well, we're thinking about that at Corning too. Which is why we're preparing our glass optical fibre products to carry the massive surge in bandwidth required for scenarios just like this. Dan's got quite the job, doesn't he? Let's go.